So welcome everyone officially to 60 Minutes in Space. During the program, you won't be able to see each other's chats, but we'll be keeping an eye on it. So if at any point you have a question, type it into the chat and I will keep track of those, and we'll have some time at the end for Dr. Lee to answer your questions. And with no further ado, I would like to introduce Dr. Steve Lee. There you are.
Well, thank you, Mitch. It's nice to be back. I guess it's been about 6 months since we've talked about Mars in any real way. Anybody that's a regular at 60 Minutes, they know that's about all I talk about. So welcome to 60 Minutes on Mars. What I'd like to do tonight is talk about, I think, 5 different Mars missions and bring you at least partially up to date on what's been going on since we last talked in June last year. And so give me just a second and I'll get my slides started here. All righty. Okay. Mitch, are the slides showing okay on your end?
Yes, they look good.
Okay, great. So February of last year was a really busy time for Mars. In May, June of the previous year was when the launch window opened every 22 months or so. And so 3 different space agencies launched spacecraft to the red planet, and they all arrived by mid-February last year. And so the first one is a really interesting mission. Well, they all are interesting, but just from the ground side of things, this is the first interplanetary mission launched by a member of the Arab world. And so this is the Emirates Mars mission, which is being run by the United Arab Emirates. It was built at University of Colorado, Lab for Atmospheric and Space Physics up in Boulder. And a lot of the science team members are US members, as well as team members from the UAE. So on February 9th of last year, the HOPE mission, also called EMM for Emirates Mars mission, eased its way into orbit around Mars. And this mission is very complementary to other missions that we have in orbit right now, but it also provides a very distinctly different data set. Many of the missions that have been sent to orbit Mars, they enter what's called a polar and a sun-synchronous orbit. And that means the spacecraft orbits from pole to pole, and the period of the orbit is such that every time it crosses the equator, it is the same time of day local time. So say we choose 2 p.m. Mars time, the spacecraft comes over, crosses the sunlit side of the planet at 2 p.m. and then it's in a 90-minute orbit. So and the planet rotates under it as well. And so when it comes around again, it's still 2 p.m., but it's looking at a different location. So that has a lot of advantages. It gives you a constant geometry and a constant lighting angle for the data, so it helps to interpret it. But what you're missing is the ability to see things that develop over the course of a Martian day. And this image was taken as the spacecraft went into its first orbit around Mars. And so this would be the early morning, the morning terminator. And so these 3 volcanoes you're seeing have just risen into the sun. And So this is really like a weather satellite view of Mars. It is not in a sun synchronous orbit. It takes about 36 hours or so to do a single orbit of the planet. The planet is rotating, the lighting angles are changing, but it gives you the entire disk. And so over the course of a couple days, you're able to see the morning in a particular location. Come back a couple days later and it will be afternoon. And so things like clouds and weather systems, dust storms, for example, that develop as a function of the time of day, this mission can monitor that. And so I just wanted to show a few of the images that have come back so far. So this is an example of a nice color view of the planet, almost fully illuminated. And the colors are constructed by having multiple colored filters on the onboard camera. And so this is an ultraviolet filter, which gives you information on clouds. This is a red filter, which primarily shows the surface features. And then this is combining all of those into along with a green and a blue filter to get a normal color view of the planet. And this is another example taken a little bit later last year. And so again, these 4 dark spots you see here are the huge volcanoes on Mars. Each one of them is between 60 and 80,000 feet tall. And all the white stuff here is water ice clouds. And so the volcanoes are actually sticking up through the cloud layer, and we're able to see the tops of the volcanoes. But the exciting thing here, again, is on this side of the planet, this is early morning, and you see it's much cloudier in the early morning because the atmosphere has cooled down when it's not illuminated by the sun. So at night, it's much cooler. The clouds form, and then when they rise into the sunlight after dawn, then they start dissipating in the solar heating. And so this is the morning side. This is the late afternoon side, just about to go into evening darkness. And so you can follow the behavior of things like these clouds over the course of the day. And so this mission is going exceedingly well. It's returning hundreds of images a month. It's also got ultraviolet instruments that look at the details of the atmosphere and the chemistry of the atmosphere. It's got some infrared instruments that complement all of these, and then the imaging is sort of a context device that lets you get higher resolution visible information on the surface and on the weather patterns, but combined with those other instruments, it gives you a very, very rich data set. Okay, so the next mission to arrive at Mars was sent from the People's Republic of China. This is their first mission to another planet. They have landed and orbited the Earth's moon, but this is their first foray into the rest of the solar system. And this is actually a very ambitious mission. It has both an orbiter and a lander, and the lander carries a rover. And so they really went for broke on their very first attempt to go to Mars. And one of the things that's I find interesting is they are very aware of public outreach. And so they've actually added a few interesting little devices that are intended just to provide PR data products. And so this was the spacecraft as it was approaching Mars, and it ejected a small sort of a CubeSat that had a camera on board. And so as the CubeSat moved away from the spacecraft, it kept snapping images, and even though it wasn't really stabilized, they got several images looking back at the mothership, and were able to get a view like this of the spacecraft approaching Mars. And so this is an artist rendition of what the spacecraft would have looked like landing. It came down in the middle of May, and so they spent about 3 months in orbit scouting out their landing site before they attempted the landing. And then once they landed, there's a rover about the size of the Mars exploration rovers, Spirit and Opportunity, so sort of golf cart sized. And the rover rolled down a ramp onto the surface. And so shortly after the landing, the United States, or NASA's Mars Reconnaissance Orbiter, flew overhead, and it was able to actually capture a view of the spacecraft on the surface. So down here, this is the parachute, all folded up on the surface behind the back shell of the lander. This is the main lander, and then this little blip here is the rover. And I think this is a closer view. So the lander, the rover, and what you're seeing here, this discoloration, is the exhaust from the retro rockets as it set down on the surface. So you have the exhaust scouring the dust from the surface, which makes the surface darker. And then since you have rockets on both sides of the lander, you get this area here where more dust actually accumulates from the sides. And so we know exactly where it landed. And this was a view from the rover looking back at the lander itself. And you see the tire tracks here. The rover came down, pirouetted in place, and then drove off to the side to get this image. And this is a view of the rover taken from the lander. And so they do their vacation photos here. And then the rover drove a few tens of meters away from the lander, and it dropped a little package on the surface that had a camera on it, similar to what they did in orbit. And so this is that camera sitting on the surface looking at the belly of the rover. And then the rover drove back to to be adjacent to the lander so they could get a family portrait. And that's all been going quite well. This is a view from the rover driving across the surface. They actually drove over to the parachute and the back shell of the entry vehicle, and I think this is something that I'm not quite sure I can imagine NASA approving, because if you got too close or there's some wild parachute lines that snag the spacecraft, that would not be a good thing. But anyway, it makes for very interesting exploration to actually take a look at the hardware that got them there. And this is driving farther away from the mothership. So there's the lander off in the distance. Okay, so those two missions we just talked about are ongoing. They're about to be celebrating their first year at Mars. And so now let's look at the various NASA missions. And so the first one I want to talk about is the InSight mission, which is a geophysical lander. We've talked a lot about this over the last several years. So this landed around Thanksgiving of 2018. So it's been on the surface of Mars for a little over 3 years. And this is just an artist's rendering of the two main instruments on board. One is a seismometer to look for seismic activity, Mars quakes, meteoroids hitting the surface, asteroids hitting the surface, spacecraft landing, anything that you can gain information by detecting these vibrations in the crust of Mars. And then the other instrument was a heat probe that was intended to burrow about 5 meters down into the surface and measure the heat escaping from the interior of the planet. And for those of you that have been regulars, we've been talking about this for since landing. There was a problem with deploying the heat probe. This is sort of like a turkey baster sized probe that was designed to hammer its way into the surface, and it just never got much beyond about 30 centimeters down, and it kept worming its way back out of the ground as they tried to deploy it. So about a year ago, that instrument was declared a total loss, and so what they've been concentrating on since then is the seismic observations. And so this is the seismometer. There's the robot arm that was used just to deploy the two instruments. And so they basically just sit back and listen to Mars. And over the course of the mission so far, they have detected with very high degree of certainty 3 different relatively sizable Mars quakes. And this is the seismic tracing, essentially the vibrations bouncing the seismometer up and down. And so that's what the raw data look like. And they are able to determine approximately where the Mars quakes are originating, and they are all in the same part of the planet. It's called Cerberus, and I'm sorry I forgot to put a map in, but it's a couple thousand kilometers from where InSight has set down. But the one thing that is interesting is in that area, the Mars Reconnaissance Orbiter with its high resolution camera has imaged a number being several dozen occurrences of where a rock has rolled downhill, or a boulder actually. And so this is inside a crater. This is the top of the crater, the rim, and we're going downhill this way. And so you see this streak here. There's the boulder with the shadow coming off of it. I think I've got a closer view here. And so the boulder, once it started rolling, it just rolled and bounced and disturbed the surface as it progressed downhill. And so that's the type of thing you can imagine if there are, boulders just sitting on a slope, happily biding their time over millennia, and then you get the ground shaking a little bit with a Mars quake that could start it rolling downhill. And so the fact that they see things like this is just corroborating evidence that indeed there is something causing these boulders to become unstable and roll from their perches downhill. So the InSight mission is solar powered, and it's got 2 large circular solar arrays, one on each side. This is just looking at one of them. This was 10 days after landing, and over the course of time, the dust in the Martian atmosphere settles out toward the surface, and things like solar panels then can actually get pretty dusty. So here we are 581 days after landing. And you can see how caked with dust that solar panel is. And so, of course, when you're operating purely on solar energy, when you start covering up the solar panels, that reduces the amount of energy coming through, or coming off the solar panels and able to charge the batteries. So over the last year, they've been sort of hunkering down and not doing a lot of things like moving the robot arm or taking a lot of images. They're just trying to run the seismometer. And that has been quite successful until just recently. And this is a view of Mars from the Mars Reconnaissance Orbiter. The little white circle is the location of the InSight lander. And this is a dust storm. And it's a fairly sizable dust storm. It's several thousand kilometers across. And it actually raised enough dust into the atmosphere that the solar panels on InSight were actually down to something much less than 10% of their normal power output. And so I think it was on January 7th, this month, that the spacecraft actually turned itself off, put itself into a protective safe mode, and then waited for the dust storm to move along and the skies to get a little bit clearer and increase the amount of sunlight reaching the solar panels. And so they just turned on again last week. I think it was the 19th. They had enough energy to start operating the spacecraft again. So that was, it reminds you that Mars is a very dusty place. And if you are relying on solar energy and you get a lot more dust in the atmosphere, then that is a potential problem. But so far, so good. They're up and running again as we speak. So this is just the recap for InSight. It's 1,126 days since landing. And this is a big difference between, as you'll see, between a geology or a geophysics mission like Curiosity or Perseverance and something like InSight. They've returned 6,300 images so far because it's not a geology mission. And they're really just doing images as documentation at this point. So that's, it's still a lot of images, but it's, I'm sure any of you with a good cell phone camera in your pocket, if you go someplace unique on vacation, you could easily take a lot more images than that if you put your mind to it. So, but the big return here from the spacecraft is these 3 Mars quakes that they've detected. Those go a long way toward being able to study what the structure, the internal structure of the planet is, and that's something we have not been able to do before. So we'll keep our fingers crossed that the solar panels don't get any dustier, or that a dust devil comes by like it did on Spirit and Opportunity and cleans them off. But so far, so good, and they're still doing their seismic observations. Okay, let's move on to the Curiosity rover, and this is the senior citizen of the bunch. Curiosity landed in August of 2012, and so we're 9.5 years since landing. Curiosity is powered by plutonium, a radioisotope generator, and so it doesn't have to worry about dust collecting on its surfaces. And so we're 3,368 days since landing, and still going strong. So let's just do a quick recap of where Curiosity is and what they've been up to. So the idea of Curiosity was to land somewhere that there was good evidence that liquid water had sculpted the landscape and had persisted in this area for a lengthy period of time. And off in the distance here is a feature called Mount Sharp. It's about 15,000 feet tall. And so it's not insubstantial by any means. And it's got lots of evidence that it was laid down underwater. And so it's a pile of sedimentary rocks. And so this is where they came down. This is Gale Crater. It's about something like 150 kilometers in diameter. And here's Mount Sharp. And this was the target for the landing of Curiosity. And the idea was to get close enough to Mount Sharp that they could drive into the foothills and start traversing up the slopes of the mountain and do geochemistry of the rocks to determine what the structure of the rocks is, what the composition of the rocks is, and to look at rocks that were laid down at different times. And so the idea, just like in the Grand Canyon, where you see the rocks or the pile of rocks exposed, the oldest rocks are on the bottom of the stack. As you progress upward, you get younger and younger. And so by analyzing, starting at the bottom and then climbing up the side of the mountain, they get an idea of how the environment in this area changed as a function of time. And so here's the high resolution view. Mount Sharp is down here. And here was the landing site. The white trace is the rover's traverse over the last 9.5 years. And you see this dark stuff here. That's a sea of sand dunes. And so that's the reason, rather than just going straight up the hill like this, that they had to parallel those sand dunes until they reached a spot where the sand was thin enough that they could safely drive across it. They didn't want to get stuck in very fine sand drifts, and so they did the safe thing, which was spend several years getting ready to get to where they could start climbing up Mount Sharp. And so this is just zooming in a little bit here, and you can see we're just starting to get into the foothills now of Mount Sharp. And here's where the spacecraft is sitting as of today. So here's just some views that the rover has gathered on its traverse over the last many years. This is very nearby right now, and so this is part of the foothills, and Mount Sharp sort of slopes up off to the left here. And this is a selfie that the rover took using a camera on the end of its robot arm. And again, you can see the type of terrain that they're traversing right now. And this is a part of a 360-degree panorama that Curiosity just took in the last few months. So this is giving a very nice documentation of the locale that they're sitting in right now. So I wanted to play a quick video just to give you an overview by the one of the lead scientists on the Curiosity mission, telling you where they've been and what they've been up to.
terrain around the Curiosity rover is beginning to look very different. The rover has driven over 16 miles since landing in Gale Crater in 2012. This view is from 1,500 feet above our landing site. We're climbing the side of Mount Sharp, a very tall mountain in the center of the crater. All of this dark material is Martian sand that's made up of broken bits of volcanic rock. Can you see the ripples that were shaped by the wind? We had to drive around this massive sand sheet as we climbed Mount Sharp. Look how clear the air is. That's because it's winter, when there's less dust in the atmosphere. You can see all the way to the rim of Gale Crater, which is about 20 miles away. We spent the last several years investigating clay-rich rocks that formed in lakes. But now we're entering a region where rocks are filled with salty minerals called sulfates. These minerals form in drier conditions, so we think this area might show us how the ancient Martian climate was changing.
Sorry.
We're starting to see lots of very cool, knobbly textured rocks like these. We think these veins and nodules were created by groundwater. Here, we recently drilled our 32nd sample of the mission. By studying the chemicals and minerals in this rock, we can learn how the ancient environment was changing as we go from the clay region into the sulfate region. And these hills are different from anything we've seen on the lower mountain. They're rounded, unlike the ridges and mesas we've seen before. Now let's look ahead to where we're going. We'll soon be entering a narrow valley that should make for some amazing images. On the left is Rafael Navarro Mountain, named after one of the mission's scientists who passed away in January of 2021. This nearby hill is huge. It's about the size of a 4-story building. This changing terrain is more than just fun to look at. It can teach us how Mars lost its water over time. How long did conditions that were favorable to life last? We're looking forward to finding out.
Okay, so that gives you the overview, and I've just got a few more sort of pretty pictures of some of the scenery along the way. This is part of the lake bed deposit, the clay minerals that they've been investigating for the last several years. And this just showing sort of the business end of the rover. This is the robotic arm, which has a turret on the end of it. There's microscope camera, the drill, which can drill into the rocks and pulverize them so that they can then collect samples and analyze them with the onboard instruments. And so this is just a view of one of the boreholes that they've done. And this is, again, in the area where the clay minerals were predominant. And all these white cracks here are, they think, where the groundwater flowed up through the rocks and it deposited gypsum, which was dissolved in the water. And so that's the a perfect rock to examine, just to look at the chemistry of how that rock might have been altered by water flowing through it. And this is just sort of the family picture of all 32 of the samples that are of the boreholes they've done so far. And you can see there's a wide range of colors that the powdered rock displays. And each one of these is related to a different composition of the rock. And so this is a good thing. If every single one of them looked like this, then I think the geologists would probably be very disappointed, because that would likely mean they're just examining the same types of rock over and over. And so the fact that you see these changes is what was hoped for. We're actually sampling different chemistries as we move across the terrain and now start climbing the side of Mount Sharp. Again, for the regulars in the audience, we've been talking about this for the last multiple years. Curiosity has 6 wheels, and they're made out of very thin aluminum. And a number of years ago, they started seeing these dents and rips in the wheels. And the surprise finding was that the sharp rocks that they were driving across, and the fact that the rover weighs a bit over a ton, actually was enough that the rocks could start poking holes in the thin aluminum of the wheels. And so that dictated then that they had to modify their approach to traversing the surface. Rather than just drive across whatever's in the way, they actually had to look for the smoothest path that they could take to get from point A to point B. And so the good thing is, even though this looks pretty ugly, it hasn't, the deterioration of the wheels has not progressed very much in the last multiple years now. So their approach to driving more deliberately and carefully is apparently working. And so this is the view from where they are right now. I think it's day 3368 or something like that. So this was 3 days ago, and this is this area that they're going to start driving through. And so here's the recap for Curiosity. Again, it's day 3368. They've driven a little over 27 kilometers so far, and almost 900,000 images returned so far. So everything's going well with the rover, and they're still planning several years in advance for where they want to explore. And so all the teams are very excited now that they're finally in the position to really start climbing up into the foothills of Mount Sharp. And as the video said, they're already seeing very different appearances of the bedrock, and certainly will be, as they analyze the future samples, will be coming up with lots of information on how the chemistry changes as a function of elevation or above the surrounding plains. And so stay tuned on Curiosity. So then the newest member on the surface of Mars is the Perseverance Rover. And again, this landed mid-February of last year. And so we're 333 days from landing, and let's see what Perseverance has been up to. So Perseverance also landed in what was thought to be a crater lake. This is a Jezero crater. It's about 100 kilometers in diameter. And what's really unique about Jezero is it's got a dry riverbed had flowed into the crater, and it actually left behind a delta. And so this is the delta fan, and this was the targeted landing site for Perseverance. And so this is just an artist's concept of how this might have looked in the past, that you had a river flowing into Jezero crater. It became a crater lake, and then out of the other side, water flowed out into the surrounding areas. And so they landed roughly here. And the idea is that this could have been, a couple billion years ago. We don't still know when the warmer, wetter periods were in Mars's past, but we do know currently you cannot have liquid water existing on the surface. It's unstable. It either freezes or just sublimates directly goes straight into the vapor phase and goes into the atmosphere. So the goal of Perseverance is to start looking for evidence of life on this area of Mars. And so they're collecting samples as they traverse the surface. They've got something like it's 50 some sample tubes that they bore into the surface, collect a core sample, and then they seal that sample tube up, and for the moment they're storing it on board the spacecraft. But eventually, when they get to areas that will be easily found, they will deposit some number of these sample tubes on the surface. And the idea is later in the 2020s, another mission will launch to Mars. It will land very near this same location. It will have what's called a fetch rover that will go out and collect the samples that Perseverance has dropped off, and then come back to the landing spacecraft and load it into a rocket that blasts itself into Mars orbit, and then it rendezvous with an orbiting spacecraft, which picks up the samples and then returns them to Earth in the early 2030s. And so the whole idea of Perseverance is to characterize with great care these samples that it's collecting, and to really come up with prime candidates for areas that, if there had been microbial life, that perhaps the chemistry of that life has been preserved in these samples. And so here's the view of that dry riverbed flowing into the crater, and here is that delta that I mentioned earlier. And so the landing site that they came down in is roughly right here. And so they're just a couple kilometers from the edge of the delta. And so here was the plan. This was the landing site, and it was decided that they would traverse off in this direction and characterize the lake bed, if you will, and the deposits that were laid down away from where the delta is, but still likely had material washing in from this stream that was flowing into the crater. And so they're basically right here, right now. But then the idea is they're going to retrace their steps, get back to the landing site, and then head off in this other direction and keep characterizing the rocks as they go. And then once they're here, they'll decide how to best sample the delta. And in all likelihood, what they're going to, they're going to do is sort of traverse up into the riverbed and collect samples along the way. And so this is the actual path they've taken so far. And so right now, this is where Perseverance is sitting. So they had made it this far, and they've already started the return path back up to the landing site. So I wanted to do a quick video of just recapping what's gone on since landing over the course of this last year.
Confirmed. In the 10 months since the rover has landed, we've been busy, and it's been a year of perseverance. From operating during COVID to the challenges we experienced with sampling to interpreting the scientific results. It's such an appropriate name for the vehicle, but also for the team and the mission itself. This mission has a series of firsts that will help future generations understand more about our solar system. One of my favorite moments was seeing our first rock core sample, looking down the tube when it was still in the drill bit and confirming that it was indeed a success. Now that we've collected the samples, everyone wants to know when and how they'll be coming back. We can't wait for the future mission to pick them up and ferry them to Earth to analyze if any of them show signs of ancient life.
The first flight of a powered aircraft to another planet.
Another highlight of this year was working with the helicopter team to deploy Ingenuity and experience the first powered flight on another planet. It was so amazing to see the team adapt to the environmental changes in order to keep flying. The helicopter has become a real asset and partner to our science team. It feels great to be part of making history. What motivates us as engineers and scientists exploring another planet is the opportunity to continuously learn more. Now that we've toured the floor of Gale Crater, we look forward to investigating the delta, a part of the crater where a river fed into a lake in the distant past. It's almost as if we're starting a new mission because we'll start to cover new ground and make new scientific discoveries. What I'm most proud of is the team, how we operate the rover, overcome challenges, and the dedication that everyone brings to their job each and every day.
All right.
All right. Okay, so just a few more pretty pictures of what they've seen along the way. Lots of these sand ripples, which is, you know, what you'd expect in a cold, dry environment now, which has a fair amount of wind blowing. And of course, the obligatory view of the tire tracks left behind. And this is the area that they've been in for the last month or so, just before they turned around. And so this type of rock is what they think is lake floor sediments. And so these are clay minerals so far that were laid down by the water carrying fine clay minerals in, and then dropping them once it reached the deeper water. So the one thing that I find interesting, just looking at these, is the rocks that they're traversing or seeing. If you compare them to what we see with Curiosity, Curiosity is really a lot of broken, jagged stuff, and as is evidenced by the wheels deteriorating. Perseverance, the rocks just appear to be much softer in outline. They tend to be rounded edges, and you can easily believe that this sort of stuff was being eroded by flowing water at some point. And you also see these layers in the bedrock, which again is good indication that conditions came and went as these rocks were being laid down. And so you know, hopefully with some of the samples, it'll be like testing different layers of an onion that that they'll be able to decipher once we get these samples back. And so here's something you may have heard in the news just recently. They were just collecting the 7th sample, and the mechanism actually jammed. And so this is a view of the sample core inside the drill bit. And there's a mechanism here where the robot arm would come and insert the drill bit into this receptacle, and then the arm would uncouple from the drill bit, and the sample container would be sealed and then moved on this carousel to where it would be stored. And this, on the 7th sample, when they tried to insert the drill bit or the core into the receptacle here, it didn't go all the way in. And once they pulled the core out and used the robot arm camera to look up close, they saw that there were a couple of little pebbles that had fallen out of the sample tube, and they were essentially blocking well, ruining the tolerances that you need to have the core sample all the way into this device before it can unlock and process it. And so here's a closer up view. And these are fairly tiny. They're like a little bit less than a centimeter across, but they're in a bad spot if they are going to jam the works for processing the samples. And so what they've ended up doing after analyzing it for multiple weeks is to just keep rotating this carousel that this device is part of, and at the same time use the percussion on the robot arm on the drill to actually send some vibrations into the spacecraft and hopefully dislodge those pebbles. And in fact, that worked. So as of yesterday, I think they've taken more images of this, and the debris seems to be gone. They actually poured all of that sample back out onto the surface so they can reuse the sample tube. And so they expect they'll go back and try to collect another sample of that same rock, and be much more aware of all the angles involved, so that any crumbly stuff doesn't come out and do the same thing that they had here. So I think I'm going to skip the next few slides because we've already heard about the helicopter. I just wanted to show a couple close-up views of when that was released last, I think it was April. And so it's been going great guns since it was deployed. It's waiting for its 19th mission right now, and that same dust storm that blew over the inside area has also affected the Gale Crater. And so they've waited until that storm passes. There's two problems. One, again, the solar power. This is has solar cells on the top of the little drone. And the second is the turbulence induced by the dust storm itself that makes the flying conditions less desirable. So they postponed by a week or so, and they expect to be doing this flight actually yesterday, I believe, if it hasn't happened already. So this is the first time in history that an aircraft on another planet has been postponed due to bad weather. So that's another first for this mission. Okay, well, let's just skip that. These are views from the cameras on board the helicopter, and just a view from the color camera looking out toward the horizon. And in the very upper left corner, there's Perseverance sitting off in the distance. And so they actually have progressed from the helicopter just being a technology demonstration system to actually making it an operational part of the mission. So they've been sort of leapfrogging over Perseverance, where they get these high resolution overhead views of the area that Perseverance is about to drive across. And so they're using the data from the helicopter to help them in their planning for the traverses. So this is that map again. So the yellow line is the path that the helicopter has taken on all of its journeys. And so here's where the helicopter's sitting right now. And again, there's where the rover is. And so the helicopter is also flying itself back toward the landing site. And the main constraint is they need to be able to have direct line of sight between the rover and the helicopter in order to transmit the data from the helicopter back to the rover and then to the ground. And so the rover has to actually come back a little bit more before they can progress beyond the current plan for Flight 19. So again, just a few more pictures, and I won't keep you waiting, but the helicopter is actually in this picture, and it took me a while to see it, but it's right there. And so they are keeping an eye on their little drone companion. Okay, so here's a 360-degree panorama that Perseverance took in December. And so I want to end with a video discussing what you can see in this panorama.
This enhanced color mosaic from the Perseverance Rover on Mars allows our team to walk right into the scene in Gale Crater. This is a combination of images taken by Mastcam Z, so it's incredibly rich in detail. The blue sky is an indication of the enhancement we have done to the image. If you were on Mars, everything would appear pink, including the sky. By enhancing the image, we make it easier for the science team to use our everyday experience to interpret the landscape. The mountains that you see in the background are the rim of the crater. They're more than half a mile high and about 6 miles away. That canyon was carved by a river about 3.5 billion years ago, when the climate of Mars was very different from today. The cliff-like brown hills you see here are more evidence of that river. These are part of the delta. When the river hit Lake Jezero, its mud and sand were deposited on the crater floor. One of the most scientifically interesting aspects of this mosaic is this whitish area here, which the science team has been calling the bacon strip, based on its appearance. We think this is a layer of mud deposited on the lake bottom, now turned to rock. That mud layer is important because it may be the best place to look for evidence of Martian life that could have lived in Lake Jezero. The large boulders on the delta are another interesting target for investigation by Perseverance. The boulders very likely washed down from far up the river channel, from places too far away for the rover to ever go. They're a gift that allows us to learn about what's far beyond the crater. As soon as we're done with our investigation on the crater floor, on smaller rocks like these, which we think are volcanic, we'd like to move quickly to the delta. But unfortunately, Perseverance has to take a longer route to avoid these sand dunes. Mosaics like this one help us learn more about the ancient Martian environment and provide new clues to where to seek evidence of ancient microbial life. We're just getting started on our long journey through the crater.
Okay, so I just wanted to leave you with this. This is the most recent selfie that Perseverance has done, and this is where it's sitting right now. Just in, I think it was late November, they got this nice sunset looking over toward the rim of Gale Crater, and this is that river valley sort of cutting through the crater wall. And so I'm going to leave you with this recap so far for Perseverance. It's day 333. It's driven 2.8 kilometers so far and returned a little over 200,000 images, which isn't bad for a little less than a year of exploring Mars. And so I will leave this up. If you would like to check some of these things out yourself, go to this website, and it's sort of the mother lode of at least NASA's Mars missions. Every single mission that's active, the orbiters, the rovers, the landers, are all have paths to the mission websites through this master list. So I think I'll leave it with that and try to answer a few questions.
All right. Thank you so much for that. That was wonderful. And for anyone out there, we understand it's a school night, so if you need to leave, we totally understand. Thank you so much for joining us. If you'd like to stick around, though, we have a few minutes for some questions, and we've got a lot of great questions in the chat. So let's jump right in. Way back at the beginning, a lot of people were wondering if the United Arab Emirates shares their data with other countries, or what that arrangement is like.
Yes, they do share. Like most missions, there's a proprietary period on the data where when it comes in, the quick look stuff gets released very quickly, but then the detailed calibrated data takes many months. Well, not many months, but takes several months to do the processing. And so that level of data, they give the science team first crack at before it's released to the public. And I think the way this works is every 3 months, or it's 3 or 4 months, I forget which, there's a sort of another deposit of data into the publicly available archives. So it's they're definitely sharing, and a good part of the science team are U.S. scientists and European scientists, in addition to the Emirates.
Well, great. And then we had several questions about how the Mars quakes are measured. Is it a similar system to the Richter scale on Earth, or?
I believe so. I mean, the Richter scale is basically giving some sort of a metric for how much energy is released in the course of the quake. And I believe the numbers I've seen for the 3 quakes that they have detected with InSight, it was something in the neighborhood of the equivalent of a 4 on the Richter scale. So big enough that you would certainly feel it if you're somewhere nearby, but not so big that it's going to, cause devastation to the landscape. But the whole idea, regardless of how strong these quakes are, is to be able to look at the details of that signal, and that then they can start teasing out how thick the crust is, if there's a mantle, is it a liquid core on Mars, how big is the core, things like that. So they're hoping for as many Mars quakes as they can detect, and the longer they listen, the better the data set becomes.
All right. And we also have several other questions about how do you know it's water and not some other liquid or lava causing these formations on Mars?
Well, lava is easy because lava, you would see the thick deposits left behind. Lava channels are very characteristically different than water channels. But water is, I mean, it's physically and chemically the most plausible liquid that you would have. Something like liquid carbon dioxide, which some people have thought about, would require much, much higher atmospheric pressures in order to stay liquid. Anything else, there just isn't enough of it around to do this sort of thing. So we know that Mars has a fair amount of water frozen in the polar caps, in permafrost deposits across large sections of the planet. So there's water there. What we need is higher temperatures and higher atmospheric pressures to make it stable so that it can carve things like river channels. And the one way, and it's some areas you see this, like in the huge canyon systems where you have permafrost under the surface, and then there's a nearby volcanic eruption that covers the surface, and the heat from that melts the permafrost, and then catastrophically it escapes and floods across the surface. So you have something like the Great Lakes draining over the course of a couple of weeks, and that causes sort of a massive signature on the surface. So it's all consistent.
All right. It's lucky that we've been studying water and rocks on Earth for so long.
Well, true.
So a couple of questions about dust on solar panels. How much of a surprise was it that the solar panels got covered with dust? And is there anything they can do to clean them?
Okay, it's not a surprise at all. Most, like Spirit and Opportunity, if you remember them, they were initially designed as 90-day missions. And the reasoning for that was the time period that they thought the dust would collect sufficiently to turn the power off to the rovers. But what happened for, excuse me, both of those missions is dust devils ended up sweeping the dust away. On InSight, they do not have a direct mechanism that they can clean the panels. I think the expectation was that the wind could blow the fine stuff away, a la Spirit and Opportunity. That hasn't really happened to the same extent. But what they have tried is using that sample scoop on the arm to scoop up some soil and dump it on top of the rover, on top of the lander, I'm sorry. And if they do it when they think that there should be a likelihood of some wind, then that sort of drifts to the side. It's coarser material than what the dust is. And so that helps clean at least a little patch of the solar panels. And they've done that a number of times, and it actually worked. It didn't clean the entire panel, but it gave them something like 5% more power coming out of the panels. So if we're in a bad situation right now because Mars is about as far from the sun as it gets in the course of its orbit. So that reduces the solar energy just because of the distance. And then the dust has accumulated, and now we're heading into the dustier part of the Martian year. So, I expect that they will be able to continue operating. The seismometer itself doesn't require a whole lot of power. And most of the power then is to transmit, to use the radio system to transmit the data back to the Earth. And so they're sort of good stewards of the energy budget. I think there's every expectation it's going to survive at least through the end of its primary mission, which would be 2 Mars years, and that would be sometime after the end of this year. So we'll see.
And speaking of Martian time, we had a question. Do the investigators on the Martian missions, are they on a Mars calendar or an Earth calendar?
Well, they're on a Mars. I mean, they know what day of the year it is on Mars. I don't think they live their outside lives based on that calendar. But they're in the early part of each mission. The teams do adopt the Martian day, which is 24 hours, 37 minutes, and that's just until the spacecraft is fully fully deployed and everything is working, and they've got all the planning in place for how this is going to work and all the operations. They want to be operating, letting the lander dictate what they do when, rather than saying, okay, we're not going to do anything because it's the middle of the night, even though it's noontime on Mars. So that's what they do. Although I think they learned a lesson on Spirit and Opportunity, because the idea there was that those missions were going to only be 90 days long. And so all of the mission teams adopted the Martian day. They had Martian watches, Martian alarm clocks, whatever. And they were going to do that for the first 90 days. And it worked, but especially the people that were local, like engineers and scientists at JPL in California, when they get off work, they have to go home to a family, and they're 12 hours off from whatever the local clock says it is. That's a problem. And so I think they learned from that, and there's a few people that they keep in the early parts of the mission operating on spacecraft time, but most of the people, they work on Earth clocks, and they get around that by doing multi-day planning. So typically they'll do a 3-day plan and transmit it up to the spacecraft, and so once it's on board, the commands are on board the spacecraft. It doesn't really matter if somebody is sitting watching when the data come back down. So that helps.
Well, that ties right into another question, which is, how much are the rovers controlled manually and how much is it pre-programmed? And how long does it take to send those instructions?
There's on the ground, there's the whole process about coming up with the plan, and that plan is written in software or in commands to the spacecraft. And I think once they, it takes a day or more for all that to be vetted, make sure that the commands aren't going to violate something, cause a problem on the spacecraft. And then once they transmit it, I mean, it's just the light time is somewhere between 20 and 45 minutes, depending on where Mars is in the sky and in its orbit. but both of the rovers, in many ways, are fairly autonomous. Once you tell them what to do, that I want you to drill over here, it knows how to get the arm there. That's part of the commanding. And then there's various limits that they expect a certain amount of force to be required to keep the drill on the surface and not have it bouncing around. And so if something isn't going according to plan, then it just shuts itself off and waits for help. But things like driving, and I think this image that's on the screen right now is a great example. Forget about the letters, but just the tracks with the rover off in the distance. You typically are not saying, drive 5 meters, turn 10 degrees, go another 10 meters, turn left 5 degrees again. You say, go over there, and you just tell it where you want it to be. And it has all these cameras on board that are looking at where the wheels are, what's in front of them, and it makes a 3D map of the surface. And so they have built in that they can only climb over obstacles that are a certain height, or a certain tilt, or you don't want it to go into a severely shaded area, i.e. a cliff that isn't sunlit. And so the rovers are actually pretty good at figuring out their own way. They can drive around obstacles. If the slope gets too steep, then they stop. They try to back up. They try to go a slightly different way. And so they've actually had a couple of drives for over 200 meters, I think, in a single day, doing this automatic driving procedure. So, there's a lot of, some of the stuff takes a lot more work, but some of the stuff is sort of a standard set of commands that just go do X, Y, and Z, and it knows how to do that.
All right, very cool. And now a question not about Mars. Can you give us any updates on the James Webb Space Telescope?
Yes, and yes, it's where it needs to be. The amazing news is all of the deployments that they needed to do have been successful. So it's a fully deployed spacecraft at this point. I think it was Monday they did the small mid-course correction using the onboard rocket thrusters to capture it in orbit around this Lagrange point, which is 1 million miles away from Earth. So you have the sun, the Earth, and then the Lagrange point. And so that point in space, it's almost like there's a little planet sitting there, and you can actually orbit around that point. It's a gravitationally stable point. And so they're in the correct orbit now. And what is left to do is focus the telescope. It's got 18 separate hexagonal mirrors that make this, it's like a 6.5 meter diameter mirror. And so each one of those mirrors has to be moved around and even flexed a little bit to change the shape of it. And so that's what they call the collimation of the mirror. And that's going to take somewhere between 4 and 6 months to do. They just very, very, very tiny tweaks to do that. And then once it's done, they'll turn it over to the engineers to calibrate all the instruments, and then the science will start about 6 months from now. So I fully expect that Kachun, the next time he does a 60 minutes in space, will go in great depth into what Webb has accomplished so far, and what it's, why it's going to be such a totally groundbreaking instrument or groundbreaking facility to have in space finally. So you can look forward to that. But the good news is everything is going absolutely perfectly at this point.
That's
Considering
great.
it's probably the most complicated spacecraft that's ever been attempted, that's saying a lot.
All right. And then I think maybe just one or two more questions, getting a little past time. Do you know anything about this SpaceX rocket that's going to crash into the moon?
I've read a little bit about it. So it's the second stage of I forget what mission it was on, a satellite to geosynchronous orbit, I believe. And it was launched several years ago. And it's just, its orbital path now is taking it straight toward the moon. So it will crash, and they know exactly when it will crash. I think it's in March sometime. And I mean, it's not a terribly unusual thing. Most of the, if a rocket is going into low Earth orbit, like the space station altitude, the upper stages, almost always now the procedure is that you would do a firing after you've dropped off the payload, and that would drop the stage out of orbit, and so it would burn up in the Earth's atmosphere. But once you get out to geosynchronous orbits where communication satellites sit, what they almost always do is then do a thruster firing to raise the orbit of that second stage so that it is beyond causing any problems to those satellites. If it happens to hit the moon, then it's not going to hurt the moon, and it removes some space debris in the process. So, but what's exciting is, since they know exactly when it's happening, there are a number of spacecraft orbiting the moon right now with some really good cameras and instruments on board. So if their orbits are such that they could actually be watching when the impact happens, we'd learn something. And certainly they'll eventually be crossing over where the impact site is, so you'll be able to see what kind of damage it does to the surface and makes a new crater.
All right, very cool. That'll be exciting. All right, one last question.
Okay.
Who names the craters on Mars?
Oh gosh, it's I think the official body is the International Astronomical Union, and they have a like a subcommittee for naming features on planets or moons. And but there's a whole process where you being somebody, scientists typically, can suggest a name for a particular feature, and you give a reason for why that name would be a good name, and then it goes up to this committee in the IAU. I think the one thing you'll notice, and don't mix these two up, on the missions, like where the rovers are doing, is the teams operating the rovers and operating the instruments, they have sort of nicknames for rocks. Like they mentioned in that one video that this is Mount such and such, named after a team member who passed away. So things like that, those are large enough features. But they probably weren't named previously because you'd just be seeing them from orbit. So there's a chance that will become official as an honor to that person. But they name like rocks that they're going to sample. So you have, Bugs Bunny is a rock because it's got a couple of little bumps on it that maybe somebody thinks it looks like bunny ears. And so that's just to help the teams, rather than calling it, rock XY 135-A. They say, oh, well, let's go look at Bugs Bunny, and everybody sort of knows what that is. But those are not official names.
Gotcha.
That doesn't get recorded forever.
But if they get through the process, they could be.
Yes.
All right. Well, I think that's all the time we have tonight. Thank you so much, Dr. Lee, for this wonderful presentation. Thank you so much for everyone joining us. We hope to see you the last Wednesday of next month for our next 60 Minutes in Space. And yeah, everyone have a wonderful evening.
Everyone take care. Good to virtually see you again.
Yeah. All right. And
Okay.
good night.
Bye.